Okay, here's our week 17 review video. The general equation that you need to have memorized for tomorrow is y equals p. P stands for principal. It's the starting value. 1 plus r, which is your percentage. N is like the monthly, weekly, semi-annually, annually, quarterly. It's that number. So how many times that happens in a year, to the n t, and t is the number of years. So like if n was monthly, n might be 12, and if t was 5 years, t might be 5 years. All right, just so you kind of make sense of what the difference is between those. When you see the word continuously, know that that one looks a little bit different. So that one is y equals p e to the rt power, or pert. Same, r and t still mean the same thing. So does p. Remember, e is a constant on your calculator. So for each of these questions, if we read through, if I look at question 2, I just kind of want to see, first of all, which type of interest this is. So this just says annual interest, which means I'm not going to be using the continuous or the PERT formula. I'm going to be using the other one. So I need to say 1,000, that's my starting value. This is my R, but remember I need to change it to a decimal. So when I move it 2 times, that becomes 0.055. N and T, they don't, well, N is annual, so that's just 1 time per year, and T they don't give me, so T is going to be my X value, or you may write down that T is a question mark. So my formula is y equals 1,000, 1 plus 0.055 over 1, and then to the 1 times T power. Look up at the formula that you just wrote down if you aren't sure where I'm getting any of that from. And then because I have a variable, I can't actually type that in, so I'm going to plug this in to my y equals in my calculator and use the table to answer. So we're going to use the table. And in the table, you're not actually going to have this 12.9 years. You're just going to have, you're going to know it's somewhere between 12 and 13, but that it's closer to 13 years. So don't worry about the rounding tomorrow. You should be able to get a good enough answer. So just know that. Okay, the one below, if you read the one below, you should notice that this one is now comparing, which means I'm going to have 2 equations. So because you're comparing, you should have 2 different equations that you're going to end up writing. One for Emmanuel and one for Kelsey. So if I write Emmanuel's, I have my p-value. It says both of them have the same interest rate. It's annual interest, so that's 1. And I don't know, it says how much longer, so that's, my t is going to be an x. So for Emmanuel, I'm going to write the equation 3,600, 1 plus 0.038. Remember, always move the decimal on your percentage, over 1 to the 1t. And then when I go to write Kelsey's, I'm going to have 2,400, 1 plus 0.038 over 1 to the 1t. Remember, the only thing different is how much they're investing. The question is, how much longer is it going to take Kelsey to reach 10,000 than Emmanuel? So we need to first figure out how long will it take each of them to reach 10,000, and for that, we're going to use the table. Emmanuel's is somewhere around 28 years, and then Kelsey's is somewhere around 39 years. So if the question is asking how much longer, you should notice here that this is more like 11 years longer. They're saying 10.9. Don't worry about the rounding. If you have 11 years, that'll be correct. Okay, in this next little section, all we're doing is rewriting in a different format. So if it gives you log, remember you're just saying 18 to the x power equals y. 64 to the negative 1/2 power equals 1/8. And then on 6 and 7, we're going the other direction. So 20 is my base, so you can say log of 20 to the 6th power equals n. So just kind of remember that circle every time. Same thing on number 7, m is the base. 8 is the exponent, so it goes on the other side, and n is my answer, so that goes right here. So you just have to remember that kind of circular pattern every single time. All right, 8 and 9, I'll do a better job on your test tomorrow of getting these set up so you know when I want you to use the calculator and when I want you to use the same base. But remember, this is 4 to the y power equals 1/16. And then I want the same base, so I'm going to break 16 down. That's 4 times 4. So I know I've got 4y equals 1 over 4 squared. And you all remember, to undo fractions or to make a reciprocal happen here, we have to use negative exponents. So that means I'm going to have 4y equals 4 to the negative 2. And now that the bases are the same, you should be able to see that means the exponents will be the same too. You can kind of quote unquote drop the base. So there, my answer is going to be y equals negative 2. All right, on question number 9, this one's similar, except now they're telling me I need to use a base of 7. So I'm going to break 343 down, and that's going to be 7 times 49, 7 times 7. That's 7 to the third power, because there's 3 there. So 7y equals 7 to the third. And now that my bases are the same, I can drop the bases, and I have y equals 3. These last two problems tell us to use a calculator to approximate. Remember, your calculator, you cannot type a base 4, so we have to use change of base formula, which means I need to do log of the big number divided by log of the base. When you do that, you're going to get 0.243. That is officially your answer, but notice I've also told you that I want you to check your answer. So remember, to check it, you do the base, and this is the exponent, 0.04243, and we want to make sure that that's somewhere around 1.4. And I am getting 1.4 or so in my calculator, so I know that's correct. All right, same idea on this other one. You'll just actually type in natural log of 46. You can type natural logs in right away, and you should get 3.829. And to check it, so that's what we think our answer is. To check, remember the base of natural log is always e. So we're going to do e to the 3.829 power. And here I'm getting 46.02, which is close enough to what I need, so I know that what I have is correct. All right, on the back here, remember you always want to read and figure out what type of compounding is this. How many times is it compounding, or is it compounding continuously? So the first thing I notice is this is compounding quarterly, which means I do have an n value, and my n value for quarterly is 4. They give me an interest rate of 2%. So for R, that's 0.02. They give me a principal or an initial amount of $1,200. And I don't know T, they're asking me when. So T is my question mark here. So my formula is going to be y equals 1,200, 1 plus R over N to the N times T power. This is something always you're going to use the table to solve. And in your table, it's not going to go as close as decimals, so you're just going to say roughly 11 years. You should notice somewhere around 11 years that this investment reaches $1,500. Okay, in my second equation, this one it says we're talking about 2 accounts, which means I'm going to be comparing and I'm going to need to make 2 equations. So first I want to figure out everything about account A. So account A they give me a rate. Remember to move the decimal place, that's 0.0324. Compounded continuously, so that means I'm going to use my E equation. So account A is going to be, well, let me kind of put a pin in that. All right, my other account is account B. They give me the rate again. So here that rate is 0.0325. And this time we're compounded semi-annually, which means N is going to equal 2. Remember, continuously meant I had the E. You may notice that the part that's missing is the principal. And we talked about in class, if they don't give you a principal, you just get to pick an easy number. So I don't know, to me, an easy number is 100. You can pick whatever number you want to there. So now let me come back to writing my equation for A. That means my equation is 100. And then it's continuously, so that's e to the RT power, 0.0324 t. And then my second account, account B, I'm going to start with the same amount. This time it's compounded semi-annually, so that's 1 plus R, 0.0325, over N, semi-annually is twice a year, to the NT power, so that's 2T. And now you want to figure out, it's saying which one will maximize interest. Well, obviously she wants the one that chooses the most. So if you plug both of these into the table, you're just comparing which one has more interest every single time. And obviously, when you do that, you're going to notice that account A has higher interest every single time. Like every time, it's going to be earning more money than account B, even though they're starting with the same value. All right, last little word problem here. So Jocelyn, again, we're going to be comparing. So we're going to be doing two different equations. So we have Jocelyn, who invests $1,200, earns 2.4% annual interest. Okay, so I see a few things there. I've got a p-value of $1,200. I have an interest rate here of 0.024. I'm moving the decimal twice. Annual means I'm going to be using n equals 1. When I read Marcus, Marcus invests $400. That's my p-value. Account that earns 5.2%, so 0.052. And annual interest means, again, this annual means I'm going to have n equals 1. So every time you're going to have an n value unless it says continuous like it did in question 13. Okay, it wants to say, when does the value of Marcus equal the value of Jocelyn? So we're going to write our two equations. So we've got Jocelyn. She's going to have 1,200, 1 plus 0.024 over 1 to the 1 times t power. And then we have Marcus, who is 400, 1 plus 0.052 over 1 to the 1t power. You're going to type both of these in the table at the same time, just like we did with 13. So this is going to be y1 and y2 in our table. And what we're trying to do is figure out when are they going to be the same. And ours is not going to be super quite as specific, but you should notice somewhere around 41 years that they get very, very close. And the amount there, I'm not sure how specific yours is, but I think the amount you might estimate is somewhere around 3170 or maybe 3150. But you're just kind of estimating that that's around the same time that they get close. Tomorrow, don't worry about rounding. It's going to be very obvious what I want you to write down. Okay, this is the same thing as it was on the other side. Base to the exponent equals the answer. Base to the exponent equals the answer. And then we just undo that. So this is my base, which is why I'm writing 361 down there. All right, and then my exponent is going to go on the other side of the equal sign. So equals equals -1/2 out here, and then answer in the middle. Same idea for 18. Base n is at the bottom. The exponent goes on the other side, and the answer goes here with the log. This is a pattern you have to know. All right, 19 and 20, remember I'll have these set up a little bit differently for you tomorrow just so you know what I want you to do. But this is 2 to the y power equals 64, which means I need to make a common base of 2. So I need to break 64 down into as many 2's as I can. So that's 2 and 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. And if I count up, that is 1, 2, 3, 4, 5, 6. You can always use your calculator to check. 2 to the y equals 2 to the 6. And now that my bases are the same, they can drop out, and y will equal 6. All right, same idea on the other side. I need to break down, this is 6 to the y power equals 1 over 216. So I need to break down 216. So that's 6 and 36. which is also 6 and 6, so that's 3. So that means I've got 6y to the 1 over 6 to the third. Remember, I've got a fraction here, and to fix fractions, we need to use negative exponents. They give us reciprocals. So this is now 6 to the y equals 6 to the negative third. And now that my bases are the same, again, they drop away, and my answer is going to be y equals -3. Finally, at the end, so the last few, you're just typing in your calculator because it says to do that. So if you type this in your calculator, you get 1.758. And then remember to check it. Natural log, the base is always e. So this is e to the 1.758. And for that, I get 5.8, which is exactly what I wanted. Remember, your answer is what you got the very first time. The bottom part is just the check. On this other one, you remember your calculator will only do base 10, so you have to do change of base, which is log of 31 divided by log of 4. Well, not equals 4, divided by log of 4, which is going to give you 2.48. And then we want to, so we think that's the answer, and we just want to check it and make sure we're right. And so now we can actually use the base that they give us. So this is 4 to the 2.48 power. And for that, I get 31.12, which is pretty darn close to 31, so I know that I'm correct.